Now we can discuss about the next topic, which is sampling variation. Let us discuss about sampling variation. We have already discussed about the sampling funnel, that we will have a population. On top of that population, you come up with a sampling frame, and using simple random sampling, you come up with a sample. That's your sampling funnel, right? So assume that these are the 4 numbers which are part of your population, and you're coming up with a few samples of size 2. So here is your first sample of size 2. You have randomly picked 2 numbers from this population. Here is your second sample with size 2. You have randomly picked 2 numbers from population. So on and so forth. You have 6 samples. So how many samples you have? 6 samples. And what is the size of the sample? It is 2. Right? And if I calculate the sample mean, the average of sample mean varies from one sample to another. If you see here, sample mean varies. That is the first property. Second property is that it varies, right? So I'm trying to get to this. I'm trying to get to this random variable. So the values vary. It is called as variable. And the sample mean can be different than your population mean. If I calculate the average for these 4 numbers, I'll get a value. That value would be most likely different than your sample mean. Most likely it will be different than your sample mean. That's one part. And each value here has an associated chance or probability associated with it. Hence it is called as random. Since it varies, it is called as variable. Since it has probability or chance associated, it is called as random. Hence sample mean is a random variable. If you're wondering on how did you get the probability values, think about this. If you roll a die once, you can get 1, 2, 3, 4, 5 or a 6. And we have already discussed that probability associated with getting a 1 is 1 by 6. Probability associated with getting a 2 is 1 by 6. Probability of getting a 3 is 1 by 6, so on and so forth. Now look at these values. You can represent these values as a set. You have 29, 30, 33, 33, 36 and 37. So here also you have 6 values. Probability associated with each value is once again 1 by 6. Probability associated with this is 1 by 6, so on and so forth. I'm simply applying the probability formula here. Number of interested events, which is 1 event here, divided by total number of events. Total number of events is 6. Alright. That's one thing that you need to understand about sampling variation. Each sample varies. Right? With each sample you get a different sample mean. And now let me explain you about central limit theorem. This is how central limit theorem works. I mean, in your school days you might have learned about central limit theorem without the essence on why we are learning, but here you are learning for a purpose now. If population follows normal distribution, then the sample mean will also follow normal distribution. First point. Second point. If the population does not follow normal distribution, still your sample mean would follow normal distribution provided the sample size is large. How large? We are going to discuss that. So this is your X bar. Right? I repeat. If population follows normal distribution, then sample mean will also follow normal distribution. That's first point. Second point is, if population does not follow normal distribution, still your sample mean follows normal distribution. However, here there is a condition to be satisfied, and the condition is that sample size should be large. All right. Another terminology, new terminology that you need to be aware of here is as follows. Standard deviation measures the variability within a single sample. However, how do you measure the variability between different samples? Variability within a single sample variation is measured using a standard deviation. However, variability between different samples is measured using another measure called a standard error. And standard error is given this formula, which is sigma over square root n. Right? So standard deviation measures the variability within a sample. Variability between samples is measured using standard error. So these are a few things that you need to remember. Now, here in the second point, if the population does not follow normal distribution, your sample mean still follows normal distribution provided sample size is large. How large should the sample size be? Let us discuss that. So the generic thumb rule is that choose a data set of 30 data points, but it may or may not be adequate. Say you're working in NASA. Getting data of 30 satellite launches would be overwhelming. You might not get that data. At the same time, if you're working in a manufacturing plant, right? If you're working in a manufacturing plant which manufactures 10,000 shirts per day, then picking only 30 shirts to do your quality inspection might not be sufficient. Probably you need to pick 1,000 shirts maybe. So 30 is just a thumb rule. What do you do with 30 data points? You try to use these 30 data points to come up with some precise sample size. So what you exactly do in this scenario is as follows. Say you're collecting weights of the people. Initially you pick weights of 30 people. Weight of first person is 30 kgs, assume. Weight of second person is 40 kgs. Weight of third person is 27 kgs. So on and so forth. You have weights of all 30 people. 30th person's weight is say 87 kgs. Given this data, you can always calculate the mean of the data. Right? It's simple. Addition of all the numbers divided by total number of values. And you can also calculate the standard deviation of the data. Post which you can use these two calculations in skewness formula, which is x minus mu divided by sigma whole raised to the power 3. If this is your sample, the formula slightly changes to x minus x bar divided by s whole cube, because for a sample, mean is represented using x bar and standard deviation using s. Right? How do you do that? Say mean is 20, standard deviation is 6. Assume for now. So how do you get this x minus mu as sigma? X is 30 here, so 30 minus 20 divided by 6 whole cube. For second one, for this one it is 40 minus 20 by 6 whole cube, so on and so forth. So if you calculate all those values and take a summation, you get skewness. Say the skewness value happens to be 2 in this scenario. All you do is you substitute in this equation, which is n greater than 10 times of skewness square, which is 2 square, which implies n should be greater than 40. So the next time you calculate or you collect the data of 40 individuals, say weight of first person is 70 kgs, second person is 27, third person's weight is 82, so on and so forth. You collect weight of 40 people and say the 47th person's weight is 97 kgs. You once again calculate the mean and standard deviation and you substitute in the skewness formula once again, which is x minus x bar by s whole cube. And you'll get another skewness value. Say this time you got a skewness value of 3. Then you substitute in this equation. N should be greater than 10 times of skewness square, which implies n should be greater than 3 square is 9, 9 multiplied by 10 is 90 there. So this time, third time you calculate or you collect the data of 90 individuals, weights of 90 individuals, and then once again you can calculate the mean, standard deviation, substitute in this equation or in this formula of skewness, you'll get a different skewness value. Either you can do it using skewness or you can do it using kurtosis. Kurtosis formula is x minus x bar by s whole raised to the power 4 minus 3. That's your kurtosis basically, right? So either use kurtosis and substitute in this equation or calculate skewness and substitute in this equation and then calculate the sample size. And this is an ongoing process and would never end. Do you think the weather forecast ends somewhere? Weather department is going to forecast tomorrow's temperature, right? And tomorrow is 21st July. Tomorrow they're going to forecast temperature for 22nd. On 22nd they're going to forecast the temperature for 23rd. So this is an ongoing process, hence you keep revising your sample size frequently on daily basis if it's weather report. If it's your stock market data, probably you need to update once in every hour. So it depends on the business scenario that you're dealing with. First time sample size you take is 30. Second time sample size, if you calculate skewness and substitute, might also become 20. Third time sample size might become 90. Fourth time you might want to collect 50. So it keeps varying basically. Alright. So we will stop this particular tutorial here. And in the next tutorial we'll discuss about confidence intervals, so on and so forth.